Hello students. Let us discuss about a topic which is the charged particle moving in a uniform magnetic field. Based on this topic we'll be deciding two cases. Okay. The case number one will be when we place a particle parallel or the anti-parallel to the magnetic field, and what will be the force experienced by the particle that we have to see. Second case that we'll be seeing that when we place a particle at an angle 90 degree or perpendicular to the magnetic field, and what will be the force experienced by it. And the third case will be saying that if I place a particle other than 0, 90 and 180, then what will be the force experienced by the particle that we have to see. Let us see the first case. So the first case is case number 1. So case number 1, if I discuss, case 1 is when a particle is placed parallel or anti-parallel to the magnetic field. Okay, so the parallel or the anti-parallel to the magnetic field, we have a formula that magnetic force formula is Fm is equals to QVB sine theta. Now if I place, suppose this is a magnetic field, you are placing the particle in this direction. Suppose your particle is moving along this direction. Like suppose if we consider a proton. So if the proton is moving along the direction of the magnetic field, then the force experienced. Now we know this is and this magnetic field and the electron both are moving along the same direction. If it is moving along the same direction, we consider that the angle between the two will be 0 degree. Okay, so if it is 0 degree, if I put 0 here, so it will be QVB sine 0. So the answer will be sine 0. It will be explained by the charged particle will be equals to 0. Now let us discuss about the second case. So the second case is case number 2 is that when a particle is placed perpendicular to the magnetic field. Okay, so if it is placed perpendicular to the magnetic field, suppose we have a magnetic field like if I consider this is your magnetic field, a uniform magnetic field which is directing towards downward direction. It is a uniform magnetic field. Okay, uniform magnetic field means having the value of same magnetic field strength at every point. Okay, and the direction of the uniform magnetic field, since it is given as cross, this means that the magnetic field is directing towards inwards. If it is dot, it is towards outwards. You can take any one. Now suppose if I consider here the top point is written that the particle is placed perpendicular to the magnetic field. So if I place a particle perpendicular to the magnetic field, like suppose if I place a particle in this way, this is the direction of the particle. That means your magnetic field is in this way and a particle is moving in this direction, that is towards me. Okay, so if it is towards me, so what will be the force experienced now? We know that the Fleming's left hand rule, force, field, current. Okay, so the particle, that is, suppose if I consider that as a proton, so the force, field, current. Field is towards downward direction, current is towards, will be in this way. Okay, this is a magnetic field, this is a current direction, this is towards me, and the direction of the force will be towards the downward direction. So here the direction of the force will be towards the downward direction, in this way. This will be the direction of the force. Okay, now what will happen, since the direction of the force is towards the downward direction, your particle will be moving towards the downward direction, it will be slightly moving away towards downward direction. Okay, same way again if I use the Fleming's left hand rule at this point, the direction of the force will be acting towards this end. Okay, then again the particle will be moving towards the downward direction. Same way the particle again will be experiencing a force towards this direction. So the force experienced by the particle will be, if it moves in a, you can see this will be following a circular path. That means always remember that when a particle is placed perpendicular to the magnetic field, the force experienced will be a circular force. That means a particle will be moving in a circular path, as you can see in the diagram. Okay, this will be moving in a circular path. Now what we need to do, we need to find out what will be the radius of the circle, what will be the time period of the circle, and what will be the frequency. Okay, now as we know, if a particle moves in a circular path, this is nothing only due to centripetal force. But who is providing the centripetal force here? the centripetal force is being provided by the magnetic force because of perpendicular force that is acting towards the inside direction. That is only because of the magnetic force. That means here the centripetal force is provided by the magnetic force. Let us see what is the magnetic force. Magnetic force experienced by the particle will be Fm will be equals to QVB. Okay, why I am using only QVB? Because it will be QVB sin 90 degree and sin 90 value is equals to 1. I am not using that value because sin 90 will be equals to 1, so QVB into 1 it will be QVB only. So mark this is equation number 1. Now this magnetic force is providing the necessary centripetal force. Now magnetic force is providing the necessary centripetal force. Okay, now let us use this. Here we can write QVB is equals to mv square by r. This is the formula for the centripetal force. Now from here I can determine the value of the radius. So r I can write this v and 1v will be cancelled here. So this I can write as mv by qb. So this is the radius of the circle. So I can mark this is equation number 2. Okay, so this is the radius of the circle projected here. Same way, if I want to calculate the time period, okay, the time period I can write as time period t is equals to, okay, t is equals to, it is distance divided by speed. Okay, distance divided by speed. Now since the particle is moving in a circular path, so the distance moving will be considered as the circumference of the circle. So this will be 2 pi r. The speed of the particle is v. So 2 pi r by v I can write in place of radius I can write as 2 pi r. In place of r I can write mv by qb divided by v. So this v and this v will be getting cancelled, so it will be 2 pi m by qb. So this is the time period. I can mark this is equation number 3. So this is the formula for the time period. Now let us calculate the frequency also. Frequency, as we know, frequency is the inverse of time period. Okay, so the frequency I can write, frequency will be equals to inverse of time period 1 by t. So this I can put it as a reciprocal. So it will be qb by 2 pi m. So this is the formula for the frequency. Okay, so these are the terms that we need to calculate in case number 2. So in the next class we'll be discussing case 3, that means when we place a particle other than 0, 90 and 180 in the magnetic field. Okay, thank you.